So welcome everyone to part two. The part one, we delved into the traditional workflow for denture planning and conversions in general to do at the same day in office. And today we are going to talk about the transition. So if you're looking to get into the digital workflow, how to transition from the analog to the digital. So where do we start? Um, you have to start with the lingo. There's a lot of new names if you're not familiar with. There's different design softwares. There's different ways of getting your there's printing, there's milling, there's different implant planning softwares, and there's a lot of different files also. So one thing that you have to understand and is get comfortable with is STL files. STL file is the standard file for any design software, and that's what you need in order to start designing your cases on whatever software you prefer. And also, if you need to start, if you need to send your files to milling or printing, they'll have to be in STLs also. So what are the steps for the digital workflow? Everything starts with data acquisition, and then is the design, and then will be the manufacturing. So data acquisition, if your doctors have an intraoral scanner, all they need to do is send you the STL files and you're good to go and start designing. Most of the files, they are open like that, and they should come in centric relation from your dentist. Sometimes they do have the tendency to close the holes. There's an option on the software that allows you to close the holes. You don't want that because you might need to, if you want to extend the borders of your scan, or if you need to print a model, you need to have that open format in order to create the bases and send it to your printer. If you don't have, or your doctors don't have an intraoral scanner, but you want to start digitalizing your cases and start designing, you need to get a desktop scanner, and you can either scan the impressions or the models. It doesn't matter. The scanners, most of them now, they allow you to scan both options, and you also have to scan the bite. So some scanners, like the 3Shape, they have the swinging arm, so you most likely have to secure them with glue or something else. Like I have a DOF scanner, so that I just introduce my articulator inside and it scans the bite. So there's different scanners. Whatever you feel more comfortable with, you just need to get one in order to start visualizing your model so you can start designing. Designing softwares, the most popular 3Shape, ExoCAD, those are the softwares that you have to pay in order to use them. And there's others like Mesh Mixer and Medilink that they're free. Mesh Mixer is not designed for dental, but you can definitely use it for dental. And there's a lot of things out there. If you go to YouTube, there's a lot of tutorials how to do things. I just know Mesh Mixer. I just use it for what I need, the basics. And I'll go through some today. But Mesh Mixer can be overwhelming, but it's a really good way to get started. If you don't have any design software, you can just download Mesh Mixer and accept the STL files from your doctors and be able at least to see that you have all the data to continue, even to create just a model and have it printed. Medilink is also free. I discovered that when I got on my, I have an intraoral scanner, I have the Medi 500, and the Medilink is also a great software that you can use. You don't need to have the intraoral scanner for that software. You can do a lot of things with that also, and what I like the most is the model builder. You can just import your scans in there, and it creates your models ready to send to the printer. Blender, it's a new software, at least for me, for the last years. It became very popular. Mostly there's different modules in there, but mostly for bars. There's a way that you can extract a bar from your design without having to go through the regular bar design that you normally would in a 3Shape and ExoCAD. And then we have the manufacturing, and we have the additive that where the printers are classified, is you're creating your object when you're adding layer by layer. And then you have the mills that they're subtracting your product. It comes from a subtraction of that big puck into your desired as a denture or whatever you're trying to mill. So what are the difference with analog and digital? Not many. You just need to get comfortable with the software, but they're pretty much the same. And here I'm just comparing the different steps that we would have on the analog and the two other main softwares. And they all start with planning your models into the right centric relation, and how to create that path of insertion to remove the, the concavities and have to make sure that your denture feeds passively. And also how to design the teeth. They're pretty much, they follow the same workflow that you would do with the analog. Different design, different 3Shape follows a different order than exocad, but they all do the same. Now, comparing when you start setting your teeth, the analog, once you remove those teeth, they're gone. So you have to be very diligent when you're planning your case. With the digital design, the digital softwares, with the design softwares, you can just superimpose data over data, so you never lose your pre-op. So you're able to see if you're following the right tooth mold and the size and the position. So it gives you that advantage in relation with the analog. And then designing the borders. This is not the best the best picture for the analog gingiva, but that's the only one that I could find. But basically, they all follow the same category. Whatever you're doing on the analog, you're going to be doing on your design software. And then, of course, setting the teeth and festooning the gums and have it ready to move to the next step that will be manufacturing. So what is your digital workflow combo? And this is, if you're looking for that transition, this is what you need to figure out. What kind of software will you be using? 3Shape, exocad, those are the main ones. It's not one that is better than the other. It really depends, like everything, whatever you feel more comfortable with. And if you're using those, are you going to supplement with others that are free, like the MetaLink? And once you decide what software you want to use, then you'll have to decide what is your product going to be. Are you going to mill it? Are you going to print it? What kind of resins or materials you want to use? I don't do any milling in-house. Whatever I need to be milled, I outsource to a milling center, and it will be only for PMMAs, like for finals. I print everything in-house. So if you decide to print in-house, you also have to look at what kind of resins you want to use in your laboratory, and also what type of printer, because one has to go with the other. If you decide to choose a certain resin, you have to make sure that is validated for the printer that you're using. And this is the very, very first printed denture that I did, not design, because at the time when I received those files, the STL files that I couldn't even open because I had no clue even what I had to do with them, I outsourced the design, and I got a printer, and this was my very first print, and far away kind of doesn't look that bad, but then if you zoom in, you can see that the quality was not good. And it took a lot of glazing and smoothing and finishing to make it look pretty to be used for that conversion. Also, the stents, it was clear, like the resin would say, but the printer was not the best because it will give you those layers that were very, very difficult to remove. You had to spend a lot of time with those type of dentures back then. So you have to really look into what kind of resin you want and what kind of printer you want to use, because they are combined. You cannot just pick some sort of resin and then print it, use another printer and combine them together. Last time on part one, we went over the traditional workflow, right? When you design your denture and then you design your stent, you process your denture and then you have to process your stent, and that is basically duplicating your denture into clear material. So if you remember, or if you know, if you didn't see that part one, but if you know, doing that stent is it's time consuming. It's tedious, it's not difficult, but you only use it in the mouth for like 10 minutes, and there's so much work to doing it, because you have to duplicate the denture and then inject clear acrylic and then finish, and then still open the treads for the windows for the multi-unit abutments, and it takes a lot of time. So once you get into the digital workflow, and if there's something that you can get out of this presentation, is this, that now if you have an STL file from that denture that you design, you can, in less than 5 minutes, import it to Mesh Mixer. Again, it can be very overwhelming software, but once you learn what to do for that specific step that you're looking for, like this one, is very, very simple. And I can always send it to you later, the cheat paper with all the codes. But basically what you do, you're just selecting the area that you want to open those lingual windows for your multi-unit abutments. And then there's a big hole in there. You're trying to merge different parts of that denture together. So basically you're bridging little parts together, because the really cool thing about this software is that if there's an option that if it sees that you have data with tiny holes, it will automatically close them all for you. And this is what it's doing right now. You made from one big hole, you made tiny ones, and the software automatically just close them all. And after that, you just need to smooth the borders and the edges, and then you're ready to send your STL to your printer to be printed for your stent. So this is really, really cool. And again, I can send you the cheat file that I have with the little codes for this if you want to, or someone can share them later. So my digital combo that I decided was to use exocad, and the resin is Flexera, and of course Flexera has to be printed on the Einstein or Envision One, whatever desktop health printers are available. Again, this is what I decided to do based on what I learned in the past and what I feel more comfortable in terms of the software. And the Flexera, I just love that resin. I've been implementing it in my laboratory, and I just love everything about it. So if you decide to use Flexera, and this is towards Flexera because it's what I use, but whatever resin you use and you decide to use, make sure that it's validated for your workflow, because you cannot use a resin in a different printer if it's not validated for that, and then a different curing unit. So for the Flexera, if I want to use the Flexera, I have to use a roller. There's particles of inside the Flexera, the Smile Ultra Plus, that they need to be mixed thoroughly. So you have to roll those bottles constantly. And then it has to be printed on the Einstein, or again, any other desktop health printer. And it has to be cured in the AutoFlash. And you cannot deviate from this workflow, because if you do, you risk the chance of breakages and maybe not entirely cure resins, and you don't want that. You want to make sure that you follow the right protocol, the FDA validated workflow for that resin that you are wanting to use. And this is just a couple of shots of the Flexera. I love it. It blends well. The patients love the color, and even the Flexera base that I use for the dentures, it blends really well, even doing the conversion with the acrylic that we're using to pick up the cylinders. And we're transitioned to printed dentures for conversion since last year. And we are very happy. I'm not going back to acrylic dentures or the traditional dentures, because everyone just loves the product in general. And one of the reasons that I chose Flexera is because of the properties that it has to absorb those forces. So I saw this video, like, oh man, this is what we need. Because when we do a conversion, these are for patients that they either have a couple of teeth in the mouth or no teeth at all, and you give them a temporary, and you tell them, now you have to follow the soft diet. You cannot eat anything that you cannot eat with a plastic. You cannot eat anything. Oh my goodness. Anything that you cannot cut with a plastic fork. This is what every single doctor or assistant tells these patients. But what happens with these patients? They didn't have teeth before. They start getting comfortable. A week passes to a month or two. They start getting comfortable with their teeth and with their food, and they go to the harsh food. They don't follow that soft diet. So because of that, these properties of the Flexera, that's why I did the switch. And again, we're very happy with the quality of the material and how it behaves in the mouth. So I chose exocad, and this is just a little bit of the workflow that we do. Once you transition to a design software, it's a lot easier than the analog. You can superimpose photos, you can superimpose STLs, your pre-op, and your proposal of the teeth. You can send it to your doctor, or even the patient, or the doctor can send it to the patient to see if they like it or not. You can confirm that everything follows the tooth dimensions, the tooth position, and how everything aligns together. And that's one of the main things with the digital. I feel that a lot of people tends to associate it with manufacturing, like digital is the final product is not good. You have to look at how you can utilize the data, because that's what you have to. You have a lot of data that you can superimpose and you never lose it. So you're not trimming a tooth from your model and lost it. You are able to keep that data and refer to it in case you need for some reason. So again, this is just part of the workflow. We're doing a double arch here, and it's just the tooth position, making sure we have enough bone reduction, making sure that we're following the existing position of the teeth that the patient is having, and everything else to design our dentures. And I design my dentures in the partial. Again, this is exocad. I'm sure that 3Shape has the same options, maybe different ways, but it's pretty much the same. I designed my dentures and the partial denture. I learned this from the guys at Evolve, Aston and Johnny, and they're great. And I like the partial denture because you're not locked in like you would be for a denture, and you are able to do different things within the same scene. So this is just a little bit of the workflow. So we decided to do lower. We're importing our STLs. We're making we're removing the teeth that we're going to design our denture. We're closing the holes, and then we need to bring our pre-op again, right? I removed the teeth, so I want to make sure that I follow more or less where the teeth were before. So I bring them into my design. I place my models, my STLs on my articulator, and then I start smoothing the bone down to make sure that it's even all around. And then I select the teeth and start positioning. So a really cool thing with the partial module is that if you add connectors to, if you just design your teeth and the base together, actually, let me go with the flow so it doesn't get confusing. So we're just placing the teeth, and then we're going to design our gingiva. Selecting our borders. I'm not really good with festooning yet, and I don't do dentures. All my dentures are for conversions, so everything from the flanges is going to be trimmed back, so I don't lose a lot of time in there. I'm getting better for my finals now, but for dentures, I don't lose that much time because we're going to remove all those flanges anyway. So once you're done with your gingiva design, there's this option that if you select connectors, it will separate your files and split file into files, and you have your teeth and your base separate in order to send to the printer. And if you remove the connectors, you have your monolithic denture ready to just send it to the printer, to mesh mixer to design your stent, and then send it to the printer. One thing, the connectors though, I am very, very detailist with them. I am very careful, making sure that all the indentations of those connectors are good, because I want my base to fit on my teeth, and I don't want to risk, you know, I don't want to have that much work into my assembling. So I want to make sure that everything, all the gingiva fits into my papillas. So once we're done with the designing, the file is ready to send to the printer. This is the printer. This is the software that we use. You can see that it's around like 23 minutes. It doesn't matter if you have 1, 2, or 7, whatever you can fit in the base plate, that's what you have. That's the timing that it takes. It doesn't add more time just because you're adding new files to it. And if you can see, I have an all-on-4 there ready for printing, and that's probably the tallest one. So that would be those 23 minutes that it shows. That will be the printing time for a prototype that, if you do it the same day, the entire digital workflow that we're gonna talk about on our part 3, that will be the time that would take to print that same day for the patient. So the time on the Einstein is pretty amazing. 20-ish minutes for printing the teeth. It's really, really good. Or the prototypes if you're working with the same day entire digital workflow. So once it prints, this is how it comes out. And the bases, there is a feature on the software that is the autopilot, that it just automatically places the bases in the best way possible. And this is amazing because I don't have to I don't have to try to align my dentures into my software anymore. And the really cool thing about it is that the supports are all around the flanges. There's no supports on the sockets. There's no supports on the intaglio. And it just makes the process a lot easier to, once you get it out of the printer, to bond both parts together and even clean it up. This is a copy denture that I had to do, and this was in order to have less support. I just printed vertically. It printed fine, it was great, but I would probably not try to do this again because I don't know if it works every single time. But in order to have less supports, you can definitely play with your prints, with your files around to see how far you can go in terms of you know, less supports in less desired areas. The thing is, the taller your print, the longer it's going to take. So you have to consider that if you're playing with you need to rush your case. So this is how it just fits right after the printer, after it has been washed. I normally only remove the supports after the supports for the base I remove right away. The support for the teeth, I tend to keep them until I bond both parts together. And once you assemble them, you just polish them and they're ready to go for conversion. I actually don't polish my dentures. This is actually a little bit over polished. I do glaze because at the time of the conversion, we mix different materials. We're going to add acrylic for that conversion. So I tend not to polish much because I want to glaze them after. And this is just the process of right out of the printer. So I'm removing the base plate, the base from the printer. I already removed the teeth. I already printed the teeth. They fit very, very well. I am very careful. You can see the papillas there. I want to make sure that they connect on my teeth very well, so I don't spend that much time trying to fix that. And I use an old composite syringe. I add Flexair base to it. And basically my spacing, I think, is like 4.5. So it's just a little bit of resin that I need to add. You can just brush it off the extra resin. And then I use the curing light to just stack cure, just to make sure that the teeth are in place all around. This, it takes a little bit more curing steps than, not curing steps. It takes a lot more of the light, the curing light, but just for the purpose of the video, I didn't hit that much. So once they're bonded together, I remove the support from the teeth and I send them to the auto flush. So for the auto flush, there's different timings, different each material has a different time for the proper cure. And one thing that I just learned that I had no clue is that even you have to not only the proper timing, but you have to also look at that little container, that little box that comes with your auto flash, because I believe that any kind of resin nowadays can be cured, is validated for the auto flash. You have to look at that container that comes inside, because if it gets cloudy, you need to replace it. And I had no idea that that was something that I needed to take to consider, because if it gets cloudy from the other printers, from the other prints, the light doesn't get through that little container, the tray, and it doesn't cure your material properly. So if you're having issues with your resins, check that container, because that might be one of them. And then the dentures are ready to use for the conversion. So what changes with the conversion in office, right? So before part one, we discussed traditional dentures, how to process the dentures, and detailing how to do the traditional conversion workflow in the office. Nothing changes. You can still use these dentures for the traditional way, that is, make some holes on the denture, pick up the cylinders, and go from there. It's just a different type of material. But if you want to do the traditional workflow, you can definitely just do that, because it's the only thing that changed was the denture material per se. But since 2019, there is a new system that I've been talking about it for, I think, every single webinars or talks that I do about conversions, I do mention that system, that now you don't have to make those big wide holes through the denture. You can just have that perfect screw access on your temporary right after your conversion. And that is the Smart Denture Conversion System. Like I said, it's been out since 2019. I've been blessed to start using it right away as soon as it came out. And it was a doctor in North Carolina that developed it. And it's been amazing combination for this cases now for my conversions, because I design my dentures, I print them, and then I use this system to transform my denture into prototype, and it works really, really well. So a little bit how it works. I'm not going to get into much detail. I think that a webinar back in December that we did for Zahn also, I talked a little bit about this, so you can refer to that. But basically, this is a system that you get online. You go online and you order the system through that website. And the way that it works is it has this special screw that it breaks through. So you have also, so it's a part of the kit, and it comes with a different sizes of tie bases. The short ones are 5.5, the other ones is 7.5. Just for you to have an idea, the regular cylinders from Nobel or Straumann, they are 10 millimeters. So these are definitely less than that. And the way that it works is you use this special screw. So the threads are made out of metal, and the head is made out of PEEK. And what happens is you use this screw to secure those short tie bases. And as long as your denture sits on top of those tie bases without interference, it's just like a locator. That's all you need. You inject acrylic around the cylinders, you seat the denture, there's no holes. It can freak you out a little bit at the beginning, but there's no holes, the material sets, and then you pop the denture. You force the denture to pop from the mouth, and that's where that magic screw works. That, because it's made of different materials, it just separates from each other, making that process a lot easier and faster and more convenient even. So there's also some drivers that come with the system to place those screws, those special screws, and also to remove after it breaks through. And there's also a set of drills that helps with the processing to actually make the holes on the denture and then finish up the entire temporary. So just an idea, we have surgery, we're using the surgical stent to make sure that all the abutments are in the right position. coming through the lingual. And we do exactly the same step as the traditional way. We do some blue mousse to make sure to mark where the multi-unit abutments are. And we place those tie bases with those special screws. They're called separate bolt fastener. And one thing with this system, though, is that you cannot feel, you meaning the doctor, when they're tightening the screws, they cannot feel that tightness that they feel with a metal screw. So that is something that they need to consider, because if they're looking for that tightness of making sure that the cylinder is seated correctly, they might break the screw beforehand, and you don't want that. So in this case, it's open flap, and there are a lot of doctors that want to do the pickup with open flap. I don't like to do that. We did it once, and we decided never again. I didn't propose the option to any other doctors, because I prefer to do it after suture. But if you're doing with open flap, there are some silicone sheets, and this is somewhere from Amazon. Like, I think the thickness is 1 millimeter, that you can just place through the cylinders, and then you just do your pickup on top of that. And then once it's done, the doctor or the surgeon can be suturing the gums while you're finishing up your conversion. Like I said, I don't like to do that. I like to do after suturing. So I use Teflon tape. I don't use rubber dam. I don't like it's flimsy, and it gets all over the place. I like to use Teflon tape, and this Teflon tape is like 2 inches wide, so we can stretch it, make holes, and make sure that they protect all the sutures. So there's no pulling of every once in a while you might pull a suture or two, but there's no acrylic going anywhere you don't want it. And basically you just inject acrylic all around your cylinders, and on the denture you seat it. And this is just a video of, this is actually a printer denture Flexera that it was just picked up, and this is just the process of popping the denture after the acrylic is seated, is set. So it's pretty simple. My doctors like to use this Teflon tape a lot also. From all the other materials that we try to use to cover the tissue, I think this is the best one so far. So once you pop the denture, again, there's no holes on it because you just inject acrylic all around and you seated the denture, just like you would do for a locator. There's this set of drills that you use to actually open the screw axis. So the very tiny drill marks the hole. You go from the bottom of the cylinder and marks the spot on the occlusal surface where the screw axis will be. And then the second drill just widens that hole to get to the cylinder. And that third drill just engages on that little peak head of that screw that was inside the tie base, protecting the tie base from the acrylic not getting to it. So once you remove that little pick material, you're ready to just finish all the borders and all the flanges and make it nice, pretty, ready to insert. So this is just, the differences that we looked today was from the traditional, instead of processing your denture in the flask and setting teeth and wax and all that, is a different way of having your data recreated and saved. So you design your dentures, you can print them. If you need a denture again, you can just print again the same file because it's reproducible. You have it there. So what is the advantage for the stage 2, for the finals? Because that is the beauty of this digital technology, is not so much designing a denture and being able to print it and avoid all that processing of the dentures, but being able to keep the data and merge it and use it towards your finals. So this is a case that, stage 2, and this is the very same case that I showed at the beginning for planning. The patient, we did the conversion, the patient came back for the follow-up. And you can see that, the resin is still intact. You do see a breakage there. The last tooth, sometimes they're not very diligent with, again, the food, or we have to make sure that we don't leave extra space, extra cantilever forces in there. Probably I should have cut a little bit more of the tooth that I left there. But the flexura, this is just 6 months after, I believe, and the material still looks very, very nice in the mouth. So if you remember, if you look part one, if you saw part one, if you didn't, every time I did conversion back then a traditional way, I would do a little cast and some silicone underneath to just reproduce my intaglio. And some doctors would think of this as a repair cast. So, oh, if something breaks, I can just use that cast to repair my temporary. And I always said no, because if you have a breakage in the mouth, this model was done from that same position initially. So if you have a breakage in the mouth, you don't want to bring it back to that model, because you're just going to recreate the same tension on that model. So if that happens, you want to make sure that you connect the cylinder or whatever is breaking in the mouth, because the mouth is the most passive place. But the reason that I would do this is just because moving forward to stage 2, I could already have a jig ready for the patient. So if you are able, and this is something that I started doing right away, and I would cut at least 1 or 2 visits to the doctor, because I have my prototype, I can do a quick model, I can have my implant position, I have my gingiva that I use the silicone to have it, to know exactly where it is. And then I could do a jig right away. So once the patient is ready for the finals, the patient didn't need to come back to the doctor to just take that open tray or a closed tray impression to get the implant position for the lab to do a jig. So 5 minutes after the surgery, it will save at least an appointment or 2 to the doctor, and they appreciate that. So at the beginning, I would do this model just for that purpose, to have a jig ready for the final stage, because then I didn't have to pour a model and do the gingiva, the fake gingiva, and then do a jig and then recreate the jig or recreate the new model, because the jig could not be passive. But now, since we're talking about digital technology, what if you can do something more? So that's when I went ahead and I purchased the Medit 500, because I do exactly the same thing that I used to do before, but now I can just use my scanner to just digitalize and keep a copy of my conversion. If you don't have one, you can, of course, do just a quick matrix of that, of your conversion on top of that model. I just don't think it's accurate enough to, to copy if you needed that for some reason. But since I got my Medit, I am able now to reproduce the temporary before it goes to the mouth. And this is the beauty of digital technology again, that once you have that file, you don't lose it. You can keep it, and then you can bring it into occlusion to your opponent, or if you have a double arch, you can just scan both models into centric relation, and you can keep that file. And you might not do anything with it, but what if you need to do something else? What if the patient goes away and needs a second temporary, or he needs something broke, or everything broke and they need a replacement right away? Of course, I don't trust these models to be as passive as the mouth, but if for some reason we need to use them, we can, because I digitalize my conversion, my prototype on my model. I have my vertical position intact. And guess what? I can just bring some skin bodies to my models and visualize that also. And then I can quickly just redo my entire prototype without having to have the patient coming back to the doctor for impressions and everything else. And the beauty of exocad, that I'm assuming 3Shape exactly the same, you can save as many scenes as you want into your design software. And if I have if I have this data with my temporary and my skin bodies, I can easily just pick my last file that was my monolithic dentures that I designed for my patient. And I can easily bring it to the design, make some holes on it, because now I have the skin bodies. I can make the holes, the screw axis on my denture, redesign my denture. Basically, I'm converting my denture on the software instead of doing it in the mouth, and cutting the cantilevers, make it smooth and nice to be delivered just in case something needs to be done. So this is just an extra 5 minutes or 10 that I take to do that model and that scan, but it gives me all the data that I need just in case it needs to be reproduced down the road. And then, if for some reason you need to reproduce it, you can just bring back your scans into your original file and just retransform the gums, right? Because your master cast now changed, but you can make nice and pretty for the patient to wear. And you can do it all monolithic. You can do with some coloring, some cutback, or some colorings just for a temporary, short-term temporary. Or you can also do a major cutback on your, and this is all Flexera. All these cases that I'm showing, this is all Flexera that I've been using. You can do a major cutback on the gums and then just add composite and send it to the patient. So you choose whatever material you want to use, and you have that data to be able to reproduce everything, whenever you want it. And with this, I thank you. I feel that I rushed again today, but quite not so much. We are going to be in Chicago. So here is, at least we have a lecture Saturday, and it's going to be talking about, again, the different workflows for conversions. And there we will talk a little bit more in detail in how to do this kind of cases, how to use the data and merge from one scene to the other in order to have a better prototype for our digital conversions altogether.
Yeah, we're so happy to have you join us in the ballroom, Grand Ballroom E and F. So you'll be able to see Dora, bring your questions, come join us, you get CE. It's going to be great, and we are so excited to have you. Again, Dora will be back for part 3 as well in March, and that's March 22nd, 2 p.m. Eastern. We do have a question, Dora, if that's okay.
Okay.
It is, how do you get started with Mesh Mixer? And that was from Julia.
So there was, I have very good friends that they know things, and I reach out to them and like, I need to know how to do this, and they teach me. So for a few things, but there are some courses online that, oh my goodness, I can't remember this doctor's name now. But there are some courses about Mesh Mixer that you can sign up for. And I think this was back in 2020, quarantine, that there were a lot of courses offered at that time. And I know that, oh my goodness, I wish Dr. Michael Schroeder, maybe. Oh my goodness, I can remember, but I can get that information. Julia, just reach out to me and I'll get you the link where to get that, if that's something that you are interested in. But YouTube has a lot of tutorials, and you just type whatever you want to learn, and I'm sure that you can find that on YouTube. But again, I learned it from a doctor that had a course together. And again, I didn't go through the entire course just because it's too overwhelming. I need to know how to do digital stents, and I learned how to do digital stents. I need to know how to create a model. I learn how to create a model. I go by steps because I can't just take all that information at once. But that is something that I'll go over in Chicago, Julia, if you want to join us, more into like free softwares that you can use to start doing this cases, how to create a model, how to create, well, the stent, we already went over it, but how to get started with the Mesh Mixer, because it's free and you can use it just to get started and get your feet wet with the whole data and STLs and all that.
Well, Dora, Julia thanks you so much and says that, you're doing some beautiful work. We have another question from Lubna. What is the name of the pink rubber dam from Amazon?
It's some silicone. Oh my goodness. I'll have to search it. It's been a while since I got it. And probably a while is like a year. I can get that information. He can reach out to me, and I apologize. I should know better about what I'm showing, but it's some sort of silicone. I'll find out, and I'll make sure that I'll be more prepared with that in the future. But I think if you put silicone sheet, it will show up. But I do have, I think I still have the wrapping. I still have some in the lab, so I'll snap a picture, and whoever needs it, just contact me, and I'll send it to you.
Perfect. Thomas is answering your question before. It's Dr. Michael Scherer.
Yes.
Okay.
I'm really bad with spelling names, so yes.
And Nicole wants to know, is there somewhere that she can go for several days to train on doing all the all on X conversions?
Come to me. No, I'm actually, we are planning on doing some courses soon on all on X's. So if that is something that someone is interested in, we definitely will have some courses out soon this year.
Awesome. Darius is saying hi, and he wants to know, how about denture relines?
So I don't do dentures. So I don't do relines. But if I use Q resin for my conversions, if for some reason we'll need to reline a denture that same day because we cannot load for some reason, I would use that material because it has the bonding. It bonds really well with either printed dentures or acrylic. So I would use that. I know there's some doctors, I would probably not be the best person because again, I don't do relines or dentures in general, but I know there's some doctors that they talk about some that are good for printed dentures, but I don't know that. But for the purpose of if you have a denture and it needs to be relined because you cannot load that same day for some reason, Q resin is a good material to use because it bonds to the printed denture really well. And that's what I use for my conversion. So
excellent. Thank you, Dora.